Many people who trade futures for a living don't fully understand the differences between the various roll options available to them, and more importantly, when and how to use them. What is dangerous is to simply rely upon the continuous data provided by a typical data vendor without knowing what is happening behind the scenes. If you make assumptions here without knowing the implications, then as a trader you may be risking more than just surprises. In this short presentation we look at a little known way to roll based upon the ratio adjust mechanism. We will explore both back ratio adjust and forward ratio adjust methods and how to calculate them. The fundamental difference between forward and back adjust algorithms when rolling data compared with forward ratio and backward ratio adjust algorithms is the fact that the former are additive and the latter are multiplicative. Some of you may understand this straight off the bat, but some may not. I'll do another presentation at a later time on the more common additive adjustments, but for this presentation we will concentrate on the multiplicative rolls. Cabestan Research in London gave me a great white paper explaining the concept, which I have used in this presentation, so a big thanks to those guys. Looking at table 2, the ratio back adjust, and working from the bottom row towards the top, we can see T1 and T0 as the roll dates across 3 contracts of the S&P. The prices are the closes, and I have labelled P, Q and R with the respective contract names to make it easier to interpret the maths. Now look what's happening at T1 on the 13th of June. We are dividing SPU 17 by SPM 17. In other words, dividing the most forward month by its nearest back month. This gives us the ratio of 0.9991833, in which to multiply all data points, in other words the open, high, low, close prior to that roll. So does it work? If you get a calculator and follow through the maths, you will see still on row 3 that 0.9918033 times the unadjusted close of 2440 is 2438 rounded. On row 4, applying the same ratio, we see the unadjusted close of 2428.5 multiplied by 0.9991833 is 2426.5 rounded, so the logic works. Now repeat the process until we reach the final roll at T0 on the 14th of March. Things become more complex, so let's strip back the complexity and explain it. Here we now need to look at dividing SPM 17 by SPH 17 in the same manner as we did before. 2363.1 divided by 2366.4 is 0.99860,547. But what about the ratio we had before we reached this second roll position? The point is, you must multiply this new ratio of 0.99860,547 by the old ratio of 0.9991833 to give us the cumulative adjustment of 0.99778695. It is this figure that we use to multiply the data by in each and every case. We can see that if we do that, we see that at T0 the unadjusted close was 2366.4. If we multiply this by the cumulative value of 0.99778695, we do indeed get 2361.2. Now it's a simple case of rinse and repeat, as the algorithm is clearly defined and programmable either in code or by manual design in a spreadsheet. Note, to cross-check and verify the final results, ideally, if we kept tabs on the cumulative ratios all the way through history, the cumulative value in the first row multiplied by close should bring you back to the unadjusted close in that contract. I've used Portara to run off a simple example of 1 minute bar of the S&P back to inception, and I've included the cumulative adjustments and unadjusted close as columns in the series to make this helpful. If we look at the results, we can see that the cumulative adjustment of 1.5468 55533 is multiplied by the unadjusted close of 331.0 does indeed verify the close of 331.0, and thus we can determine that the data is proportionately correct. A quick note: if we decide to reverse direction and go with a forward ratio adjust, we must be careful to get the direction of the division in the correct order, as it is not the same way around. If we look at table 1, in this case using the forward method, all the mathematical nuances are the same. However, logically the division must be the reverse of the back ratio adjust, and in this way on the 14th of March, roll date at T0, the SPH17 is divided by SPM17 to arrive at the forward ratio adjust of 1.001396471. Lastly, a cautionary note on utilising ratio adjusted data in your back testing. If you don't fully understand this method, don't use it to predict results. Ratio methods are useful for certain types of testing, but if you don't know what you're doing, the results can be very misleading. By design, data is never negative using ratio adjust. It may appear squeezed compared to back adjusted additive methods as the intuitive shape gets distorted, but you can measure the volatility of returns in terms of percentages, avoiding negativity and very small numbers close to zero, which would distort your percentage ratios, or even zero itself, and possibly a divide by zero exception if you've decided to build your algorithms with divisions instead of multiplicative factors. For example, a good use for ratio adjusted data is if you were trading two contracts, such as the bund and gold. You could, in theory, compute a volatility ratio between the two and use that to risk adjust your positions.